So for our, this is lesson 4. Algebra 1 textbook. So it's so-called Scott's workout. So we're going to see another sequence today. And we're going to model that using a table, graph, and both types of equations. So it's really a continuation of the 3 lessons that we've seen so far. So after today's lesson, you should be able to see the change between figures. How can you tell if a sequence is arithmetic, geometric, or neither? How are explicit equations different from recursive equations? And what are the advantages of using an explicit versus recursive? So, we got Scott's workout here. All right. So, Scott has decided to add push-ups to his daily exercise routine. He is keeping track of the number of push-ups he completes each day in the given bar graph, with day 1 showing that he completed 3 push-ups. After 4 days, Scott is certain he can continue this pattern of increasing the number of push-ups he completes each day. So, as always, we are going to be looking at the pattern. So students, you will look at the pattern one particular way, right? And we're going to use that method to write ourselves a equation. Could be recursive, could be explicit. So students tend to look for this pattern first. So we got this showing up each day, and they tend to see that after day 1 we have these equal groups. That I would say is the most common pattern. Let me go ahead and duplicate this without all of the patterns being shown. Okay. Students also tend to find this pattern. This is another popular one. So we got one block each day, and we have our groups separated in this manner. And then thirdly, we have this pattern where all we notice are the 2 groups. The groups of 2, that is. So we got 2 more added each day, essentially. So we have all the same stuff, and then all we know is it's the previous day plus 2. So all of these methods push us to write different equations. So if we're looking at, so let's go back to this first one. So if we're looking at this one, we can visualize this as, we can just say D for dots is equal to, well, I know I always have 3. No matter what, I have the 3 in yellow, right? I have that. That's what I color-coded in yellow. And then let's say I want to highlight, let's go to highlighter. Let's do this in blue. So we got this in blue. We have this group of 2. Let's do this group of 2. And then I'm just going to pick purple for my last group. So we have these different groups of 2 essentially. So if you notice that this has 1 group, this has 2 groups, and this has 3 groups. And if we relate it to the day, right, the number of groups is always one less than the day we're on. So we can say, okay, so we have the 3, right, plus the 2 groups the number of blocks in each group, the 2, and that's multiplied by the day. Excuse me. I'll say t. I'll say t for the day. I'm gonna actually change this. I'm gonna call this p for I'll call this p for push-ups, and I'll use d for day, because this is day 1. This is day 1, day 2, day 3, day 4. Right? So we always have the 3 plus the 2 in each group multiplied by the day minus 1. So that's the relationship between this and this, this and this, this and this. The number of groups is always 1 less. So I'll just say P for push-ups is equal to 3 plus the 2 groups, the d minus 1 groups of 2, essentially. So the d minus 1 groups of 2. So this is the 3 in each day. This is the basically 2 groups of d minus 1. So this is one explicit equation that we can find. Another explicit equation we can find, which is an equivalent equation, right, is this pattern where we have 1. So I'll say P is equal to, we always have the 1. We have the 1 plus, okay, we have 1 group here, we have 2 groups here, we have 3 groups, and then 4 groups. And how is that related to the day that we're on? Well, it's always 1. It's always, it's actually the same, right? If we have 1 group on day 1, 2 groups on day 2, 3 groups on day 3, 4 groups on day 4. So it's actually always the same, and we always have those 2 groups of D. So we always have the D groups of 2 blocks. So this was our 1 block in each day, right? That's this block right here. I'll highlight it in a color. Say yellow. So we have the 1 in each day, right? And then the 2, so we have the D groups. Ooh, I need it a little more transparent than that. So it's always the same, right? The number of groups is always the same as the day. So we have, essentially we have D groups of 2 blocks. D groups of 2 blocks. That's where those equal size groups come in handy. So this is another explicit equation that we can find. And finally, we have a recursive way of thinking, right? Here's a recursive equation. On day one, right, we have 3. And then each subsequent day, we're adding 2. So we start with 3, and then we add 2, add 2, add 2. We add 2 to the previous day. Oops. So this is our recursive way of thinking. You can use the recursive expression next equals previous plus 2 as well. That's also appropriate at this time. So yeah, we have these 3, I guess, ways of thinking about these push-ups. So how many push-ups will Scott do on day 10? Well, students like to gravitate toward recursive equations, right? So if we have f of 1 equals 3, f of n is equal to f of n minus 1 plus 2, we can start at 3, then add 2, add 2, add 2. We're going to need to do this 9 times, right? That's a lot of work, though. It's a lot of work. Let's use an explicit equation. There's nothing wrong with this method, but recursive just requires a lot of repeated work. You can use recursive equation to check your work, but I like to gravitate toward using one of our explicit equations. So we can be a little bit more formal. So the push-ups as a function of the day is equal to 2d plus 1. So on day 10, P of 10 is equal to 2 times 10 plus 1. So that is 20 plus 1, which is equal to 21. We could also use the explicit equation, the first one that we found, which was, I believe it was 3 plus 2 times d minus 1. So P of 10 is equal to 3 plus 2 times 10 minus 1. Well, that's 3 plus 2 times 9, which is really just 3 plus 18, which is indeed 21. So both methods work. Just be careful with your, do your parentheses, then multiply by 2, then add 3. So at this stage, we can add our table, we can add our recursive equation, explicit equation, and then graph our points. I'm going to go ahead and paste that now. Okay, so I went ahead and I filled in our table here. We have our graph, and we have our recursive equation and our 2 explicit equations. Again, any of these two are both valid. If we notice, our points lie on a straight line, right? So this should lead us to believe, hey, we're probably working with an arithmetic sequence. Right? And how do we know? Because each subsequent day, Scott adds on, was it 2 push-ups? So each subsequent day, Scott adds on 2 push-ups. So the important word here, the operative word, is adds. So this is where in class we would discuss with our groups, we would, share ideas, so on and so forth. So here's our exit ticket. Write a recursive equation and explicit equation for this pattern. The first term in your sequence is 2, and the next term is 5, and the pattern continues by adding 3 to get to each of the remaining terms. So I always recommend fill out your, write out your pattern. 2, and then 5, so it seems like we're adding 3. So our next term would be 8, then 11, then 14, so on and so forth. So for our recursive equation, what's our first term? F of 1 is equal to 2. And then for our recursive, f of n is equal to f of n minus 1 plus 3. So this is the next term, this is the previous term, we need to add 3. Don't forget, always list your first term. So for our explicit equation, we are going to start with f of n is equal to the first term in our sequence. And because this is the n minus 1 term, we should multiply it by n minus 1. Excuse me, I need to change this. So the number that goes in this spot is our common difference, which is 3. So 3, which is the common difference, multiply that by n minus 1, and then we need to add our first term. If we had started, this was our n equals 0 term, then our explicit equation would be slightly different, but it would be equivalent. But since in the problem it says this is the first term, we can assume that we need to use n minus 1 for the first term. Okay, that is the end of Scott's workout. I hope this was helpful. Again, just to like kind of summarize, there are 3 ways we can think of this pattern. We can think of it explicitly, with starting with 3 in each day and then adding 2 groups of d minus 1. We can think of it as all of them starting with 1 and adding d groups of 2. Or we can think of it recursively, where we're starting with 3, then adding 2 the next day, then adding 2, and then adding 2, so on and so forth. This leads us to believe that this is an arithmetic sequence, right? We're adding 2, we're adding 2, we're adding 2, right? This leads us to believe that this is an arithmetic sequence. The points lie in a straight line. So this is an arithmetic sequence. And we know this because we are adding 2 to get to each subsequent day's number of push-ups. Scott's really killing it with the workout. So we're going to go ahead and end here. Hopefully this was helpful. Leave me a comment. Let me know what you guys think. Alrighty. Thanks. Bye-bye.